Hello everybody. Today I'm going to talk to you about Kubeflow and the portability of this AI ML platform. In this demo, we are going to deploy two Kubernetes clusters with GPU capabilities. One on AKS or Azure Kubernetes Service, and the other one will be on Charmed Kubernetes deployed on EC2 machines from AWS. On those two Kubernetes clusters and using same commands and same scripts, we are going to deploy a charmed Kubeflow cluster and run the Yelp demo, which is a sentimental analysis example and algorithms that will be trained and executed using jupyterhub notebooks. First of all, let's create the AKS cluster. We will start by creating the resource group using this command. Now we can create the AKS cluster using two machines. We will use this command to create the AKS cluster. So we use the standard NC6 virtual machine type because they allow us to use NVIDIA GPU card with AKS. Now let's execute this command. It's taking some minutes to finish. Now our AKS cluster is correctly deployed, so let's retrieve the credentials to be able to use it. We use this command to retrieve the credentials. And to make GPUs in this AKS cluster nodes usable, we must deploy a daemon set for the NVIDIA device plugin. And this daemon set runs on a pod on each node to provide the required drivers for GPUs. So first, we need to create a namespace using kubectl create namespace command, and we call the namespace GPU resources. Let's create this new namespace. And we have previously created this manifest file, the NVIDIA device plugin DS. So this manifest is provided as part of the NVIDIA device plugin for Kubernetes project. Now we use kubectl apply command to create the daemon set and confirm that the NVIDIA device plugin is created successfully. Now we confirm that is created successfully, and we confirm that the GPU devices can be used with this AKS cluster. Now in another environment, let's create Charmed Kubernetes on AWS. Creating the environment is very straightforward. We will just need to clone this repository. We need to access this folder, bundle Kubeflow, and then run the script with the name of the Juju controller and the GPU tag. Of course, we did that because we previously added the credentials for AWS to let Juju access our AWS account. So now the script is bootstrapping Juju, creating the bootstrap machine, and then it will deploy Kubernetes components. This script will take several minutes. So now we have the two environments available and ready for us. Those two environments are slightly different. We can show that by executing this command. So this is the AKS environment and the charmed Kubernetes environment on top of AWS. Now we will deploy Kubeflow on both environments at the same time with the same commands. So we will start by adding those Kubernetes environment to Juju using this command. And now we can bootstrap Juju on both Kubernetes clusters. So this is gonna take some minutes, so we can accelerate that for this demo. Now the bootstrapping step is completed. We can show here that the bootstrap is completed in AKS and in the charmed Kubernetes. Now we are going to create the Kubeflow model using this command for both environments. The Kubeflow model now is a blank canvas where our Kubeflow charm operators will be deployed. Now we are ready to deploy the Kubeflow component using this Kubeflow Lite bundle. Execute that. This is gonna take as well several minutes, so we will accelerate that. So here you can see that it's deploying all the operators on both environments. So now we almost finished with the Kubeflow deployment. There is only one component that is in blocked state. So it's currently a manual step that we need to apply to correct the role of the Istio ingress gateway, and we need to deploy this, execute this command. Sorry. Here we will wait a little bit until the manual until the service become active and idle. Now the Kubeflow bundle is deployed and all the services are active and green. You can check that by executing Juju status. But you may still need to execute some commands just to make it fully functional and be able to access the dashboard. So first of all, we will need to configure the Kubeflow credentials using Juju. So we will configure the username with this command. We'll configure the username as admin and the password as password 123. Then we need to configure DEX and OEDC services with Istio Ingress Gateway Service IP. To do so, we need to execute those commands. First of all, we would execute them on the AKS environment. So we retrieve the IP address of the service, of Istio servers. Then we configure DEX and OEDC gatekeeper. And we do the same thing for the charmed Kubernetes. But we will change instead of IP host name here. Oops. I think I missed the, oh yeah. And we configure as well docs authentication service and OEDC gatekeeper. And that's it. So now we will just need to wait a bit until the service get configured, and we should be able to access Kubeflow dashboard now. Now we have access to both Kubeflow dashboard. So first of all, we need to put the admin credentials for Kubeflow. Here, admin and password 123. And here as well, admin and password 123. And you can see here that we have really the same Kubeflow environment or same Kubeflow platform that is deployed on two different platforms. Now we are going to execute the Yelp demo, but first of all, to be able to execute it, we need to create a jupyterhub notebook on both environments. Let's create a jupyterhub notebook called Yelp. We would use the GPU image for this demo. It's consuming pretty much like a lot of resources. So we will add 5 CPU, 40 gigabyte for this notebook. We will add an NVIDIA GPU driver, and we will increase a little bit the disk space. Let's create that for the, this is the AKS environment, Kubeflow on AKS, and we will do that on AWS. Let's create this. Also, we will call it EL on the GPU notebook, 5 CPU, 14, and then 1 GPU, and increase the disk space. And we need to wait a little bit because it's the first time that we add the notebook, so it needs to download the notebook image, Docker image, inside the worker nodes. Now we have the two jupyterhub notebooks created on both platforms, and we are going now to run the Yelp demo on them. So we connect to the jupyterhub notebook. First of all, we will download the repository that contains the demo. We'll do it on this platform at the beginning. So it's a Git repo. We clone it. Then we install some Python packages using pip install. We will do that as well. Oops. For the other platform. and we install the packages. Okay, so the package has been installed. Now we are able to access the Yelp demo, which is on notebook, Yelp notebook, and here on notebook, Yelp. And here, so there is one change that we need to do. We have only one GPU per worker node, and here as well. And now we are able to run all the cell. Okay, run all here, and here we can run all. It's gonna take some minutes to finish running the whole Yelp demo. Now the run is finished. All the notebook blocks has been executed. So we can take a look here. Like every block is executing, and the algorithm has been trained. And at the end, as a result, we can see that the algorithm was able to classify the Yelp reviews and classify the words and those reviews from good words, like here, and bad words, violation, blaming, everything. And we can see that it is pretty much the same result as the other platform. Thank you for watching this demo. I hope we will see each other in other demo. Thank you.